Hi, so this is first session of Snowflake training. This is more focused for data engineers. So just I will talk about topics what I'm planning to cover over a few days. So I will cover Snowflake key concepts, features, and Snowflake architecture, then data loading, data pipelines, and also I will try to cover few more important concepts. Then parallelly, I will just cover hands-on exercises as well. Something like create basic objects, database, Snowflake tables, Snowflake views, and coding scenarios like data loading and different data analytics scenarios, and how to do data transformations, different use cases in data transformations. I will pick up one real-time project. I will just try to explain and I will try to code end to end. So after this training, who are new to Snowflake, they will get complete understanding from end to end, right? Move on. So just quick intro about me. This is Raju. I'm working as a senior data architect in one of the MNC. I have experience as a data engineer. I played Snowflake architect role and data architect role. I work with multiple customers. I deliver multiple client projects. So this is my YouTube link. All right, let's move on to our topics. Okay, so unlocking power of data. Why Snowflake is popular. So these are the few concepts we'll be discussing next few minutes. Before getting into Snowflake, I just want to ask, what is data? Why it is so important, right? So these are few points about data where it would give us little idea on what is data and all. I don't want to, spend too much time on these concepts, but one, two concepts are very, very important before getting into Snowflake, right? So that is the background why I'm just talking about data and data warehouse now. So data is an enterprise most valuable asset, right? So then data to insights journey. We can leverage data to extract meaningful patterns and insights from data, right? So this is a these insights and patterns help business to grow. So that is the background. Then what are different types of data, right? Raw data. What is your understanding on raw data, right? Raw data means the data is in original format. Why we are just discussing these kind of data types and all? These terminology we'll be using in our labs, in our sessions frequently, right? So what is processed and curated data? Whatever the data transformations are applied, that data is called processed or curated data. Even some cleansing is done, right? So post transformations, the data is called processed and curated data. Then what is structured data? So the data is stored in table format or views. That is nothing but structured data. Means data is in a structured way, right? What is semi-structured data? Whatever the data you are getting as JSON file formats or XML file formats, that's examples for semi-structured data. Then what is unstructured data? Whatever the data is like video files or audio files, this data is completely comes under unstructured data. So by using this data, by leveraging this data, we'll create we'll be able to create some patterns or insights, right, which will be help business to grow, right? That's why we are saying data is an enterprise most valuable asset, right? We'll move on. What is data warehouse? data warehouse definition, it's kind of centralized data store where the data is coming from one or more data sources. Okay, so this is enterprise system mainly used for analytics and reporting, and it will help us to make real-time decisions. Help us to, in the sense, help business to make real-time decisions. So typically, structured data and semi-structured data format, right, can store current data or historical data. Means data warehouse means store historical data also along with current data for analytics purpose. So primarily, data warehouse is designed for complex queries, right, and analytics, where when you compare data warehouse with transactional database, example like Oracle database or SQL Server, right? So, what are the how are we getting data, right? We get data from different sources. Again, we'll discuss data loading and all these concepts, pipelines and all. So, just to give some examples, source examples, the data can come from websites or applications, right? Or databases, APIs, or streaming applications. Streaming application, nothing but real-time data or file systems. In some business case means scenarios where customers or business users, they will upload files directly to some FTP server and all, where our system should be able to pick up the data from that file system. It can be CSV file or it can be anything, right? So that's how I think in some projects we we may need to set up data pipelines where it should pick up the data from file systems, right? We'll move on. Next, yeah, another very important concept, OLTP and OLEP. Whether Snowflake is OLTP or OLEP, right? So it is very important concept. You will see this question almost, I would say 90% interviews for data engineer. You will have this question. So it's very important for data engineer to understand what is the clear difference between OLTP and OLAP. So OLTP definition itself, online transaction processing, where OLAP, online analytic processing, it's both OLTP, OLAP systems collect and store data in their systems. The primary purpose of OLT is to process database transactions, where primary purpose of OLAP analyze aggregated data and complex query processing. We discussed, right? OLAP means Snowflake is mainly for analytic purpose, right? Or query processing. Okay. Then OLTP usually stores real-time transactional data from single source, whereas OLAP, it stores historical data and current data from multiple sources. Okay, so that is a high difference. Again, data set size usually in gigabytes for OLTP, whereas OLAP data set size usually terabytes to petabytes. Okay, some of the use cases just for us to understand. Suppose you just process orders, right? What are the transaction data will be stored in OLTP system, or update inventory, or manage your customer records, right? All these transactions, whatever the data is getting generated, it will store in OLTP databases. To give some examples of OLTP systems, one is Oracle database or SQL Server, right? These just two examples, there are many. Then again, coming to use case of OLAP, you need to analyze trends, right? That is your requirement, for example, or your requirement is predict your customer behavior by using the data available in the system, or identify profitability. So these are all use cases you can do by using OLEP systems, not with OLTP systems, right? Because you need historical data, you need current data to generate all these analytics and insights, right? To give examples of OLEP systems, Teradata or Snowflake, or if you take AWS, it is Redshift, and you have Azure again, right? So you have a lot, so many data warehousing systems. So those are all comes under OLEP. So these are key differencing points between OLTP and OLEP. It is very important for us to understand. We need to be very clear, because this is, as I said, this is very common question, even not for interview purpose, because to execute some Snowflake use case and all, we also need to kind of understand clearly what is the difference between OLTP and OLEP. All right, let's move on to next topic. Okay, why Snowflake is so popular, right? So this is Snowflake platform diagram. I will explain one by one. So why Snowflake is so popular, right? So I want to talk about few concepts. So Snowflake is true SaaS offering, means software as service. It's a true software as service offering. No need to manage infra or software. So that's why we call Snowflake is true SaaS offering. Then Snowflake architecture is another key differentiator, where Snowflake architecture with you can do scalability is very easy. The other very important concept, storage and computes decoupled, means separate. What is the advantage if it is separate? Uh, just to give some example, suppose any organization, right? They have some high storage demand. If it is not decoupled, they need to they will be build more, because you need to purchase both storage and compute together, right? If it is decoupled, if suppose that organization has high storage demand, they will be built on only on storage, right? No need to really spend on compute, right? That is the advantage. So this is Snowflake, very powerful, strong architecture where storage and compute are separate. After Snowflake, kind of all other competitors also, they started implementing this kind of architecture. If you just take AWS Redshift, again RA3 instance, they have come up, means their RA3 instance also storage and compute is decoupled, right? So that is the advantage. So with this architecture, we can pay separately. We get bill less. We, in the sense, customer will get less bill because of this decoupled architecture. And other feature of Snowflake, performance and speed, faster query processing, because because of Snowflake architecture, high performance, the speed is high, so your queries runs faster. Then easy data sharing, with Snowflake you can do seamless data sharing between producers, systems and consumers, right? So this is another powerful feature of Snowflake. Then on-demand pricing, means whatever the usage you do, you get billed for that same, as I explained here, right? Storage and compute. So our customers get billed per second basis, means first 60 seconds will be first minute will be billed full. After that, whatever that compute, we get billing for only in seconds. Suppose 1.1 second, 1.2 seconds our compute run, 1 minute billing plus 2 seconds billing, right? You will not get charged 2 minutes billing. Whereas in some data warehouse, if it is 1.2, customers get billed for 2 minutes billing. So that is another advantage on-demand pricing means. Then security and encryption. So Snowflake, it's completely all your data at rest or data at transfer, everything it's completely encrypted, so security is so high. So these are all so many powerful features. I'm just talking very high level, very important features. There would be, I mean, so many features are there. So with this, I mean, that's how Snowflake is kind of proved as a very popular cloud data warehousing tool in the market. All right. So this is Snowflake Cloud Platform architectural diagram. I will just explain in next slide. We'll move on. Okay. So first point before getting into this, right? Snowflake accounts can be hosted on AWS or Google Cloud or Azure. Means it's kind of it can be means hosted on either Google Cloud or AWS or Azure systems. So all cloud providers it supports, right? That is one of the unique feature. And this side means the data comes from data sources. So data sources like it can be OLTP database or applications or even third-party systems or web-based systems, or it can be log-related data, or it can be sensor data coming from IoT systems. Okay, so the data means coming from all these source. It can be one source or it can be multiple sources. Then this is our Snowflake platform, and whatever we do process or analytics, whatever we do, then there will be consumers for Snowflake. So consumers, what they do, they use this data, right, from generated from Snowflake. It that is the input for reporting or visualization or data science related use cases or real-time analytics, right? So this is what data consumers. So now I will go back to Snowflake kind of I would say features or right functionality. So data engineering, right? So because Snowflake support data engineering, we can build batch data pipelines or streaming pipelines using SQL and Python coding language. So we can set up all these pipelines. So Snowflake is a very it's fit for all data engineering related use cases. Again, data lake, it's provide the benefits of data lake with security and governance. As I explained, it Snowflake can be hosted on all three. So it support all data lakes of all these three cloud providers: Google Cloud, AWS, it is S3, right? It's support that data lake with the benefits of security and governance, which is come from Snowflake. Then it will support all data warehousing related use cases, accelerate data analytics with zero maintenance. Absolutely, there is a completely, I explained it is a true SaaS, right? There is a absolutely zero maintenance, and it will support all data science related use cases. So Snowflake would help us to do data preparation for all machine learning models or machine learning data science, and also Snowflake has native connectivity to all these machine learning or data science platform. Okay, and Snowflake also can build data intensive applications. So that's how it will support data application related use cases. And the next one is data exchange. What is data exchange? So using Snowflake, we can share data securely with internal departments like within company or company vendors or suppliers, right, or partners, right? So that's how this data exchanging. So we discussed each and every component, data sources we've discussed, and how Snowflake can be hosted on three different cloud providers: Google Cloud, AWS, Azure we discussed, and then Snowflake will support all these applications and use cases: data engineering, data lake, okay, data warehouse, data science, or data applications and data exchange, right? Then uh, this would be a feed for all our data consumers, data reporting or machine learning, all right, or ad hoc analysis. So to give some examples of data reporting and visualization, Tableau reporting or Power BI or ClickView, ClickSense reporting, right? All right, we'll move on next topic. Okay, Snowflake architecture, very, very important, right? So in Snowflake architecture, we need to know there are three components: database, storage, query processing, cloud services. Anyway, we'll discuss one by one. So Snowflake architecture is combination of shared storage architecture and shared nothing. Let me highlight this one. This is shared. Okay, shared storage architecture and shared nothing compute architecture. So what it means, database storage, right? It can be shared across users, whereas compute is nothing but query processing. This query processing cannot be shared between users. So that's how the architecture, right? So just to reiterate, Snowflake architecture is combination of shared storage, share nothing, compute. Okay. So what is database storage now, right? Database storage is central repository for persistent data. Persistent data is nothing but saved data that is accessible from all compute nodes. Means once data is stored in database storage, it can be accessed by all compute nodes, right? That's what shared storage disk architecture. Whereas query processing perspective, Snowflake utilizes MPP compute clusters, means massively parallel processing cluster for query processing. Shared nothing architecture means these compute cannot be shared. Okay, shared plus shared nothing architecture. Very, very important. Okay, so because it is shared nothing architecture, performance and scale out are the features, right, at compute level, means virtual warehouse level. Every virtual warehouse is separate, performance and scale out. Okay, so very, very important in Snowflake architecture, storage and compute decoupled architecture. Then data is stored in object cloud based object storage platform based on the cloud platform we choose. What it means, our data in Snowflake, previous slides I think I explained, right? If you choose Google Cloud, so your data can be stored in Google Cloud object based storage. If it is AWS, your data will be stored on S3, right? That's what it means. So Snowflake can be hosted on these three different cloud providers: Google Cloud, AWS, or Azure. We discussed this. Okay, let me move on. Next slide. Okay, so I'll just cover a few concepts on those three components we already discussed, but I will just provide few more details. So database storage layer, it's responsible for storing and managing data, right? All data stored in single unified location, that is the database storage. So wherever you use any virtual warehouse, but the data is stored in database storage only. Okay, then when you do data loading, Snowflake platform itself recognize the data and it will do optimization. It will compress the data. It will convert the data into columnar format. Means you need not do anything, right? That's how we call Snowflake also true SaaS, right? In previous slide I explained. Okay. Then the second component is compute layer, which is used for query processing. This is the that layer. This query processing layer is responsible for process your queries using virtual warehouse, right? Suppose I'm one user and you're a different user. I'm using this virtual warehouse to process my queries. If both are kind of all these virtual warehouses are independent. Okay, so a compute layer basically responsible for data processing task, means all the complete data processing will be done in this layer only. Then each compute cluster can scale up or scale down dynamically. Dynamically in the sense based on data load, your compute cluster can scale up. Suppose the data workload get reduced, then it will get scaled down dynamically. Again, we need not worry. It will just system platform itself. It will check what is my workload, whether I need to scale up or I need to scale down. Okay. Then final layer, cloud services layer. It enable users to interact Snowflake platform and manage data, right? That is the purpose of cloud service layer. And also it will, cloud services layer is responsible for our authentication, who were logging in system and provide access to users. Okay, and the security and governance is completely managed in this layer, cloud services layer. And what are the Snowflake high performance for compute means optimization, right? Whatever optimization promise, so everything will be done within this layer, cloud services layer. So cloud services layer is responsible for optimization also. And metadata management, I'm sure, not sure how many you know metadata. So what is metadata? Metadata is definition data about data. I will explain during labs. So cloud services layer is responsible for metadata management as well. Okay. All right. I think good. We discussed Snowflake architecture, we covered, and Snowflake platform we discussed, and a few data concepts. So now we'll just do some labs, or we'll try to execute some real-time use cases. For that, we need Snowflake environment, right? So this is our Snowflake environment, where you will be able to see environment like this. So I will explain in next session. So worksheets, basically whatever you write code in worksheets. So you can write code in SQL or Python, and you also can share your worksheets in some folders also. You can create some folders. And Streamlit, it's kind of little advanced topic. I'm not going to discuss in this training plan. Dashboards, it is similar concepts like visualizations and reports, means whatever the data you do analytics, you can create Snowflake dashboards also, but it will not have so many rich functionality or so many features like license versions like Tableau, ClickView, ClickSense, or Power BI, right? But if it is a minimal reporting or visualization is enough for our customer, we can manage dashboards by using this dashboard feature. In fact, one of my customer, they have Tableau, but Tableau license are limited. Like they have very limited, like very high level business users are using Tableau licenses, probably 10 or 15, because it's kind of so much cost, right? But at the same time, So many business users or functional SMEs within customer, they want to also access for some dashboards, right? So that's where, I mean, we explored this dashboard functionality, Snowflake dashboards. We created some Snowflake dashboards by using the data available within Snowflake itself. So we can give this access to so many people, right? There is no restriction, no license restriction. Okay, so that is a kind of a advantage of Snowflake dashboards. App packages, I will not discuss much. Then data, we are going to discuss what database and all. Data products, we will not touch much, not really needed. Monitoring, definitely will touch upon few concepts. What is task history or copy history, right? Dynamic tables, it's again one of the advanced topic. I will see, I mean, whether I can cover this also in, or we'll see. Okay, so then again, admin, this is again important for us to understand how to create users, how to create roles, right? So how our billing will be done and all will, I will try to cover at least some concepts in admin through labs. Okay, so this is about Snowflake environment. So in next session, I will I will explain how to create Snowflake trial version. So next session, I will explain the whole process. All right. Okay.